What is the connection between gamma-aminobutyric acid and alcohol? Gamma-aminobutyric acid and alcohol have mutual functions in the human body. The chief relationship between them is that alcohol has similar effects to those of gamma-aminobutyric acid on the nervous system. This is because alcohol binds to and activates the same receptors that suppress the firing of neurons, which slows down activity in the central and peripheral nervous systems. In alcoholics, normal function of the neurotransmitter gamma-aminobutyric acid becomes dependent on the presence of alcohol in the bloodstream. The acronym gamma-aminobutyric acid stands for gamma-aminobutyric acid. It is the principal inhibitory neurotransmitter in the brains of humans and all other mammals. When gamma-aminobutyric acid is released by one neuron into a synapse, it binds to gamma-aminobutyric acid receptors on adjacent neurons and prevents these cells from firing by reducing their electrical excitability. Many depressants, including alcohol, can bind to gamma-aminobutyric acid receptors and trigger the same inhibitory response. Alcohol binds the class of gamma-aminobutyric acid receptor known as gamma-aminobutyric acid A. These receptors are found throughout the brain in different subtypes, where they moderate neuronal communication by inhibiting signals between neurons. Gamma-aminobutyric acid neurons are essential to neurological function, from basic control of breathing and walking ability to vision. Like most sedatives, alcohol increases the inhibitory effects of gamma-aminobutyric acid, which explains why alcohol depresses motor skills and perception. Gamma-aminobutyric acid and alcohol enhance each other's effects. Gamma-aminobutyric acid and alcohol together will have a greater effect than the same amount of alcohol or gamma-aminobutyric acid by themselves. When it binds to gamma-aminobutyric acid A receptors, alcohol is thought to increase their ion conductance, causing the neuron to become even less excitable. Alcohol also enhances gamma-aminobutyric acid absorption. Combined with other gamma-aminobutyric acid agonists like barbiturates, alcohol can increase the sedative effects of these drugs. Glutamate is the primary excitatory neurotransmitter in the brain, and neurons use it to induce electrical communication between cells. Both gamma-aminobutyric acid and alcohol oppose the effects of glutamate in the nervous system, but gamma-aminobutyric acid does this indirectly by preventing cells from firing. Alcohol opposes glutamate action by binding to glutamate receptors, but not activating them. It blocks the receptor so that glutamate cannot bind to it and excite the neuron. By doing this, alcohol further enhances the inhibitory effects of gamma-aminobutyric acid. Alcoholism changes the relationship between gamma-aminobutyric acid and alcohol. Gamma-aminobutyric acid A receptors become less sensitive to alcohol, and require larger quantities of it to respond, while glutamate receptors become hypersensitive to even smaller amounts. If an alcoholic enters alcoholism treatment, he or she may experience withdrawal symptoms that reflect the depressed function of gamma-aminobutyric acid receptors that have become dependent on alcohol. Shaking, hallucinations, even violent seizures can result from diminished gamma-aminobutyric acid response and hyperactive glutamate receptors.